Hello and welcome to EPR, your favorite environmental enthusiasts, Nic and Laura. On today's episode, Laura and I discuss caves. We talk to Chris Maupin about isotopes, grad school, and caving in Vanuatu. And finally, all elements have isotopes, but hydrogen is the only element whose isotopes have unique names. Deuterium for hydrogen with 1 neutron and tritium for hydrogen with 2 neutrons. How about that? I made me say the hard words.
I was going to say, you wrote this for me, but then you had to read it.
Yeah, right. Hit that music.
NAEP will be hosting the Advanced NEPA training virtually on August 23rd from 8 a.m. to 4:30 p.m. Eastern Time. This workshop will benefit those professionals who work in related natural resource disciplines, who work with federal land management or real estate transactions, federal agency projects or permitting, and transportation or other infrastructure projects with a NEPA review component. Check it out at www.naep.org. And now it's time for 30-second sponsor spotlight by Nic. 1, 2, 3, ready, go.
Oh man, Laura, do I have the thing for you? I say that a lot, but this time I mean it. You know, we have Nerf guns, right? And they shoot little darts at kids and, you know, you get to have fun. And if you're tired of not hurting your younger brother, I have the gun for you. It's called Muck Gun 5000. That's right. It shoots actual mud. And it's great and wonderful because while it will not cause bleeding, it will cause internal hemorrhaging. That's right. You can injure him without your parents noticing. There you go. Muck Gun 5000. Get it in stores today while supplies last. Also, we may be facing lawsuits. Too dark.
Ding, 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 within time. And again, I know that you're all enjoying these, but we would love to replace it with a sponsorship from your company. Check it out at www.environmentalprofessionalsradio.com. Now let's get to our segment.
I was going to ask you about cave diving and whether you would do that, but if that's not what you did, we don't have to talk about cave diving. Caving, we could still talk about.
Well, we could talk about both.
Yeah.
I mean, I love caves, but the safe ones.
Yes, I am right there with you. I want big open spaces. And it's like, I don't want to like push myself through a hole, just to get to the other side. It's not that I would like totally freak out. I could do it, but like, there's like, I've seen too many horror movies is really the problem. Right.
I was thinking the same thing. I've seen too many TV shows. There's always an episode at some point, if there's a little kid on the show, that they fall in a well or get trapped in something.
Right. Or it's like, I mean, like, have you seen The Descent, the movie? No. By the way, it's a criminally underrated horror movie. It is very good. It's about a group of hikers that go into spelunking into a cave. And guess what? Yeah, there's monsters in there. And, you can imagine the rest. But yeah, it's a really good movie. But that's also why I don't enjoy the idea.
Right. Any cave could have monsters, werewolves, vampires.
Mm-hmm. Exactly. Yeah.
Werewolves, vampires, bears.
Right.
And aside from just not being able to get back out.
Yeah. That's kind of it. It's like, yeah, it's just, this is it now. This is our new home for the next 12 hours because we're going to die after that. So that part kind of freaks me out a little bit. If I think too hard about it, it's kind of like when I went surfing, all I could think about, every time I stopped, I would think about sharks. But not when I was moving, not when I was doing it. It's just when it was calm, I was like, wait, sharks. It's the same kind of thing, I think.
Well, and that's why Chris was talking about not telling his students about, how challenging it was going to be ahead of time. Just like, be prepared, bring this stuff, but I'm not telling you why.
Right. Yeah. Oh, man. Yeah. And I mean, it's.
But I have been in many caves, though. Have you?
Have I been in many? No, I've been in some, been in a cave in the Galapagos. That was kind of cool.
Oh, like above ground or water one?
It was a lava tube. So it was like an old.
Oh, yeah.
Yeah, that was really cool. That was really, really neat because it's just this big open cavern, and you're like, this is where the lava went. I was like, went, right? Yeah, past tense. It's not happening now. Oh,
yeah, lava tubes are cool. I've been to 2 different ones in Hawaii. One was kind of like small, watch your head. And then the other one was huge.
Yeah, this one was big.
Yeah. And once you got towards the end, it got very, very, it was like a mile long. When you get to the end, it was very dark. And there was one point where the trail went off one way to a very, very dark place. And there were people like in flip-flops, like, maybe you shouldn't go that way.
Yeah.
Like, you guys should come over here and go this way. And then you could actually go out. There's a little hole that it went up to. You could either go out there or turn around and go all the way back. And we're like, well, let's go out. And then we got out and everyone's like, where do we go from here?
Yeah.
So it was very much like an episode of Lost.
Previously on Lost. Yeah. Oh, yeah. That's funny.
Or coming up on Lost.
Yeah. No, that's what they would say. I totally remember. I was all in on that show until the end. What a waste of time that ended up being.
Yeah, I did a workshop the other day and asked people as an icebreaker what their favorite TV show was. And one person was like, well, this isn't really what everyone else would think, but Lost.
Oh my gosh. Wow. That's crazy. That's nuts. Yeah. It's truly.
Who watches that on repeat?
Yeah. You can't. You watch it one time. You're like, why did I do this? That's too funny.
I wouldn't know. I haven't seen it.
Don't do it. Don't do it. I'm telling you right now. As a PSA for everyone, don't start. Because you're going to start it and you'll be like, oh my gosh, this show's amazing. And then it ends and you're like, I hate myself. That's what's wrong.
But yeah, cool caves. Rainbow Falls? Ruby Falls, not Rainbow. Where'd that come from? Ruby Falls I've been to many times over many decades. It's kind of nostalgic. And Carlsbad Caverns, super cool.
Yeah, I know the Luray Caverns are the ones in Virginia. That's the ones I've been there as well. It's been a long time, but that's kind of like, it's like, we're going to go hike up a mountain and hike into a cave. And that's kind of it. And yeah, those are cool. Those are really cool. I mean, I don't know if it's the coolest in the world or anything, but it's pretty big and it's pretty neat. You feel very safe in the Luray Caverns. I didn't feel like I was going to get attacked by monsters or anything.
Yeah. I mean, when I was in Paris, one of the things you could have done was go out and do some caves.
Yeah.
Do some caverns, caves, whatever. I didn't do it, but I'd like to maybe.
Yeah, you should. It's like, there's like a cave, like the longest one in the world is like in Vietnam or something. And it's just like a little hole in the ground. And then like somebody's like, let's go in the hole and see where it goes. And it goes like miles deep. It's like miles long. It's crazy. Yeah. So yeah, I don't know. So yeah, there's caves everywhere.
There are caves everywhere. That is absolutely true. How many I will go in just depends on if there's an entry fee, I'm good.
Yeah. Yeah.
I don't go in the ones that no one's managing.
Right. Oh yeah. And Sam told us that lava tubes aren't caves. They're lava tubes. So that's what the argument. Yeah. I thought that was hilarious. She's like, not caves.
I know, right? You guys are wrong. Thanks, Sam. Keeping us honest over here.
Yeah, exactly. But yeah, that's perfect. That's a good spot to end, I think. So yeah, let's get to it.
Yeah, let's talk to Chris. Welcome back to EPR. Today we have Chris Maupin, clinical research scientist at Texas A&M on the show. Chris's research is heavily involved in studies of coral reefs and climate. Welcome, Chris.
Thanks for having me.
Oh my gosh, awesome. Thank you for joining.
Yeah.
By the way, Chris.
Hey.
Nic is my co-host. We met doing the show. So we've met
bonded over against me
multiple times a week for the last 2.5 years, almost 3. And we've met in person twice.
I think I've only met you in person once. Once.
On your wedding day. So
that's right. I had Mike do the reading. Yeah. So
how are things since then?
Busy. I keep myself very, very, very busy.
I can see that.
Yeah. It's like herding cats that are radioactive and on fire sometimes. We
can't touch them or get near them, but we also need to go that way. Yeah, that's funny. That's funny.
I feel like I want to take all the questions we had prepared for today and just chuck them.
Throw them out the window.
I'm just curious, like how many students do you have?
So because I am not I'm not a professor, right? To get that out of the way, I'm on what's called the research track. So my responsibility is I co-direct and I run the Stable Isotope Geosciences Facility. So what that is it's a shared lab between a whole bunch of professors with their graduate students and undergraduates as well, who have topics where stable isotopes represent a tool that can answer or address a hypothesis. And so what ends up happening is in terms of my time in that respect, so these instruments date back to the Manhattan Project era. In fact, the exact same kind of configuration we still use for the most part is how uranium was separated and which uranium isotope, how we figured out which uranium isotope kind of has the right neutron speed to produce a critical mass. And so these instruments that I'm responsible for, you have to have someone who is comfortable doing some it's not intimidating, but it's a lot of work to keep them repaired. And so you essentially have to become like an electrical engineer. You have to these are very, very large and complex instrument systems that I'm essentially at the point where I can take them apart down to bolts and put them back together, could build them from scratch. And so what that lets my philosophy be in the lab when students come in is I usually throw them in the deep end in terms of, it kind of went through a period where a lot of this real hands-on, you break it, you fix it, technical knowledge evaporated or became very compartmentalized to a few places. I benefited tremendously from a mentor who he was originally running the Harvard Stable Isotope Lab, and for family reasons, he moved to St. Pete, where I got my master's, and basically threw me in the deep end because my master's project was all stable isotope ratios and reef building corals. And he recognized that I had the aptitude and the interest and kind of let me go wild from there. And I've kind of kept that philosophy alive. I tell students, when I throw them in the deep end, you can't break anything that we can't figure out how to fix together. And probably both of us learned something,
Right.
I try to kind of maintain an ego-free environment within the lab because there's plenty of that from their advisors, and they have to deal with a range of different, issues that are in academia. I want them to come in, and whether they're an undergrad helping out or doing a thesis project, whether they're a grad student really nervous about getting samples for their dissertation, I want them to come into an environment where all that drama stays out there. In here, we care about the science and getting you kind of what you need and the tools to be able to understand how we got there. And stable isotopes as a kind of measurement are really remarkable. We do incredible things with them. It's kind of so I work with what are called light stable isotopes. So different isotopal logs. So molecules that have different isotopic substitutions, and we measure the ratio of them, but they can tell you anything from temperatures in geologic past using coral skeletons. They can tell you a lot of my work in that kind of realm. My own personal work is using both corals, but also cave deposits, because rain, the different types of storms that rain over caves have different kind of isotopic fingerprints, and that gets transferred into the stalagmites and stalactites that rain builds. And fortunately, there's usually enough uranium in them that decays to thorium that we can also absolutely date them back to about 500,000 years. So a lot of my own paleoclimate research is geared towards that. But I
got a question for you though.
Yeah.
How did you get into that? Were you like, I want to study isotopes when you were 8 years old? What? You know what I mean? How did you?
Yeah. Okay. So, and in fact, I'm kind of a black sheep. So a lot of people who are doing that kind of work, the paleoclimate work, come from, a more geosciences background. My bachelor's is chemistry and chemistry and marine science at a place called Eckerd, which I'm sure Laura is also familiar with.
Yeah.
So I'm one of those ones where there was never any doubt, science was an escape from like, I didn't want to do anything else. Like, I'm like one of those true believers. I was just like, I'm going straight through. Like, I'm not taking no for an answer, like to any grad programs. So I got involved working with a professor at USF who reconstructed El Nino Southern Oscillation variability in Pacific coral skeletons, kind of to look at how it naturally changes and to compare it to like how it might be changing now and might change in the future. And I grew up in Florida, watching reefs die. And, it's like, and watching like a lot of habitat disappear in Florida because we had to build villages, et cetera.
5,000 everything's.
Yeah. And so that was kind of my initial like jump into climate science in general, my interest in it. And so I started getting really interested in like kind of what can we do about the problem of dying corals. So there was this intrinsic like interest in corals, but I was a chemist. And once I kind of like the light bulb clicked when it was like, so you can take these tiny carbonate samples, turn them into CO2, put them on this mass spectrometer, and it tells you about like, and it's beautiful. You can literally see the annual cycles in the isotope data. Like they are annually banded like tree rings. You get 12 samples a year, and you can just watch like a nice annual cycle and then a El Nino year, a La Nina year. And that was like,
oh, cool.
This is it. Like, this is so cool. Like, I can't believe you could do this.
Yeah.
And, but from there, on top of that interest, I just kind of got really, and being from Florida, you're always kind of this subconscious weather geek because all of us, all of us have experienced the phenomenon of hurricanes and
the power. Yes, quite literally. Yeah.
Yeah. So that kind of sold it for me. And I convinced that professor to let me do an undergraduate thesis in that lab. And so I remember like the day I defended my undergrad thesis, when they told me I had passed, he said, I have funding and I would like you to come be a grad student. And so, then I worked on, so there's a lot of coral species that people use in the Pacific that work fairly well to reconstruct these things. But in the Atlantic, it's been a much kind of more limited field. And I remember in my familiarity with coral, I remember looking through some cores and seeing a species that I was familiar with. And I was like, that will work. And my advisor, he was very, very old school, like Brown PhD, like kind of a direct lineage from kind of like some of the beginnings of my field. And so he could be fairly intimidating, but like it was always kind of, I was one of those people who he could never really like just, intimidate. Like I was like, you don't know where I'm from. Like, you don't faze me.
Yeah.
And I was like, this will work. Let me try it. This is going to be my master's project. And he was like, okay. And, but it worked, and that was my first scientific paper. We were the first ones to kind of calibrate the geochemistry of that species to kind of temperature and where it was growing. And so, that was also where I really, really got hands-on, full, like deep dive learning all about like the methodologies, the instruments, how to repair them, how they need to work, how to kind of explain to others how they work, how to teach others how to use them. And then my advisor moved to UT in Austin, and he said, I would really like for you to come help me build my lab and then be my PhD student. Because at this point, he had been doing a sabbatical at UT, but he had been hearing remotely that I had been like, you couldn't keep me away from like the instrument stuff. And you need somebody like that. And so it was like, it was a real honor to be trusted with it. And but I joke, I'm an endangered species. I'm really Florida born and raised. And so like, it's like, man, Texas. But I took a chance, went out there. It's every bit as hard. Everything you read about how much of a mental health strain it can put on you is absolutely true. Like, and it's one of the things I try now to really emphasize to the students I interact with, because it's the pressure and the kind of the way I explain it to undergraduates who are interested in grad school is you have spent the last 4 years either on scholarship or paying a lot of money or paying a lot of your parents' money to get the right answers, right? But what you're getting the right answers on are what we call the dead letters, stuff that like, is in textbooks, stuff that is, it's like when you transition to grad school, now you're actually doing science. Now you're doing stuff no one knows. You're going to come in to the lab every day and be the first person in the world to know something based on your measurements. And that sounds great. But let me tell you, it's mostly failure. And grad school has kind of the tendency to bring in the high achievers, and not every person is able to make that like mental adaptation. And it can be, I'm one of those super stubborn people where it's like, you're going to fail, but like, I couldn't let go of the attitude initially where it's like, I will not fail. Like I cannot fail. And so every part of it was a very humbling and introspective experience. I learned a lot about myself, and I learned a lot about how people are capable of treating others when there's not really any consequences. Once you have tenure, it's kind of like, what can a student do? The power dynamic there is just so different. There's so much imbalance. But the reality of it is like I'm a better mentor and a better scientist for all that. So it's kind of one of those ones where you're like, oh, I wouldn't wish anybody to go through that. But then that did make, but the best way is to kind of...
What are your top pieces of advice for grad students?
Oh, for grad students or for prospective grad students?
Well, perspective, I guess.
Well, the first one is the one I just said, be prepared to fail a lot. And the second one is take absolutely no shame in making sure that you monitor and nurture your mental health. Like the goal is, for me, I know I filled out in the survey, it's like my wife will tell you hobbies. It's like hobbies. Like, no, it's like, you can't turn it off. Like you can't turn it off ever. Like it's always thinking about like science and stuff.
I think I incorporated in your wedding somehow.
Yeah, that might have been true. I recognize myself as an extreme example, like where, for example, this job is a lot of work that's not my own research. And so like a vacation for me is getting to write and think about the science that I'm trying to get done is like bliss. So that's an extreme example. But really, it also circles back to the big picture thing. It's like, keep in mind how cool what you're doing actually is. And if that can't maintain the stoke, then don't be ashamed of being like, maybe this isn't for me. Like, I've seen a lot of people go down some dark paths who maybe should have, and it's so hard to hear because the implication is that you're a failure, but it's like, no, go be happy. Yeah. There are professors who still get angry if their students graduate and don't go into academia. And it makes me furious. And I'll tell the students, I'm like, you should be going and doing what makes you happy. And if there's anything I can do on my end to support that, it's like, this is an apprenticeship. Science is an art. Once you get past undergrad, and I'm kind of paraphrasing Michael Poligny's kind of science philosophy writings that he did, it's an art form. And in order to master how it's properly done, you have to have a direct kind of, there's a very clear like apprenticey like relationship between, and that's how it's supposed to work. So like look out for that. And if you're visiting labs, make sure you get some alone time with the current graduate students and get their perspective, because oftentimes prospective students will, especially if they're interested in a particular lab group, there's never any never any pushback when it's like, yeah, just go out and hang out with just the grad students. And grad students love to do that. And for prospective grad students, and you can get honest answers. Like, what are the pros? What are the cons? What are the kind of things to watch out for? And so,
people
what was that like? That was like 4 pieces of advice. I don't know. Like I talk about this a lot because, we have master's students who are thinking about a PhD, and we have undergrads who are like, grad school like sounds like so crazy. Like, you hear all the stories, and it's become very kind of publicized how brutal it can be. And it can be. And some of the people and some of the egos can be brutal. But you can also find real gems of mentors. And best piece of advice my advisor gave me was choose your collaborators wisely. And the professors kind of internationally that I collaborate with, I've done exactly that. They're the type of people who have the reputation, or I've witnessed personally, how they mentor their students, how they kind of work on a project with a student. To circle back to UT, it was like they also had several new hires. So my advisor came in full professor, his own lab getting built. He was an old salt. But I saw several new hires that were, that pre-tenure level of just stress and commitments and overwork. And it's like, I got a skill set that is in demand and becoming rare, and a PhD, which means there's nothing to really stop me from doing my own research. Why the hell would I want to be a professor? Like I don't. And this is just me personally. Some people love it. My closest friends love doing it, and I love supporting them any way I can. I'm often, if they run similar instruments because they're doing similar types of research, and I will drop everything to answer a call if they have a problem with their instrument or a question. And it's like, I consider it service work, and I just tell them to pay it forward whenever they can. And that's the stuff that brings me real joy. Yeah. That and actually doing the science. And the other reason was I realized that I still am so interested in doing the research myself. And when you're a professor, you're passing the responsibility of doing the research to other people. And my philosophy is much more like using my research to basically, there's usually pieces of it that are very easy. They make great first undergrad forays into real research. They're very well suited to that. And I had that benefit when I was an undergrad, and it was absolutely critical to where I am now. And so I try to keep it so that it's projects that I'm kind of interested in and doing the research on and doing the science on and directing the science myself, and kind of bringing on undergrads for aspects of it where they are, we had a recent paper where 2 undergraduates who did their thesis with me, and their projects kind of gelled together. They both presented at the largest scientific conference in the world as undergrads. One of them gave a talk. She was a total badass. I was like, are you sure? The session convener is a good friend and collaborator, and you get to choose poster or talk.
Yeah.
And I kind of warned her, said, support you either way, 100%. I just want you to know that you are going to get a talk because it's but they ended up as co-authors on a major publication that, and I kind of have gotten a little bit of flack for that, but I don't care, because my model of co-authorship is one where it's like, if the paper didn't happen without the work you did mentally, physically, you're a co-author. I don't care. You're not gonna, that's one of those hills you die on. But
I have a question. So about your research, so you get to a point where you're like, okay, we can see climate data in corals, right? So what's the next thing you use it for? Are you it's oh, hey guys, look at this. Isn't this wild and crazy? You can see this is how bad things are. This is how bad things have gotten. How do you interpret it from
Yeah. So it's funny, like that's almost kind of like not even what I'm doing anymore. A little bit. I have one small project, but in general, the idea is we want to, so a lot of the climate simulations that are done, they have limitations because of how big the grid cells are. Like they can't simulate individual storms. They can't and sometimes there's uncertainty between different models about both the sign and the magnitude of change. Mm-hmm. And so for the coral example, what we're really looking for is our instrumental records of like sea surface condition variability are so short that the only way to really extend them to look at what a kind of pre-anthropogenic baseline of variability is to push the instrumental record back using these things, that we refer to as proxies. And it's with the stuff I'm most involved in right now is kind of the severe and extreme weather aspects of it. Because if you think about a climatology, it's going to be built up of these individual like storm events and things like that. And that's what you're actually integrating into your climate archive. And so most of my effort right now goes into kind of trying to understand what controls the isotope variability and the rainfall that makes it to the cave. So this is how I ended up starting to collaborate with the phenomenal. If anybody out there, I'm definitely about to do a plug. So if anyone out there is looking for a undergraduate meteorology program, Texas A&M, the professors work harder than anywhere. I mean, it just blows my mind because these are students who they may not go to grad school, but they will likely stay in weather in some capacity. And many of them may end up in National Weather Service offices, and their mission will be to protect life and property. And so the science communication aspect, like drilling all of that stuff home, the professors in this department take it so seriously. For example, like the course that I've been privileged enough to tag along with for my own research purposes, it's like literally like how you kind of forecast and then go intercept and observe scientifically like severe storms. Like essentially like, yeah, I know. It's amazing, isn't it?
It's so wild. Laura couldn't help herself. Yeah.
I mean, so it's essentially like, you're getting these students out to teach them how to safely observe like things like tornadic supercells in the field and what they might do. So like,
are you storm chasing essentially?
Storm chasing has controversial, this is not the amateur hour stuff. This is like, they learn how to forecast. We launch weather balloons at sites that are at severe risk and send that data to relevant National Weather Service offices to inform them like what the atmosphere is doing, how unstable it is, and things like that. And then I work on kind of trying to track how isotopes change through the physics of these storms, because it's an example of like why you should always like be open to being the dumbest one in the room. And like, it's like, I knew nothing. And now it's like, I get to collaborate with some phenomenal people who understand the value of like working with isotopes. It's like, you tell them like, yeah, there's 3 different masses of water that we can measure, and they all have different kinetics and they all have different thermodynamics. And so you're essentially adding 2 more degrees of freedom to studying thunderstorm processes. So for them, it has potential. And then for me, for my work, it helps me understand what's really controlling. How can I realistically interpret these long speleothem or stalagmite and stalactite records that contain, 400,000 years of rainfall data from these areas like Central Texas, where we get severe storms. And so those folks are incredible. So yeah, that's a long plug, but there's they're good pals, and they've been very kind and open-minded and letting me tag along, and they have seen me put in the work and try to learn all this stuff, which the oceanography background helps because it's all fluid and the physics and the math are all the same.
I have another question for you. I've got to ask, because I assume, we do a segment on the show called Field Notes where we ask people to share fun stories of them being in the field. And I assume you have got to have some good field stories.
I can. Okay. So let me put it this way. Let's see that course. So essentially one of the main things we do is that I'm interested in is collecting hail. So you have to basically figure out how to get behind these supercells that have dumped these massive hailstones. Then you have to find it before it melts, collect it, bring it back to the lab, keep it frozen. And so kind of getting the hang of that was it took 2 years to be successful, but it was now we're kind of getting the hang of it. So that's kind of crazy. Hail is the most economically devastating consequence of severe weather in the country. It's by far the most expensive. And you're really kind of going through these I can't drive through here, trees down, stuff like that. But yeah, it would be so impossible I could spend days telling y'all stories. I mean, so my PhD field work was in Vanuatu in the Solomon Islands, doing,
really?
So my PhD.
This is why we ask, Chris.
Yeah.
We want to hear this.
My PhD samples for the cave stuff are from Guadalcanal, and I collected those in 2010. And on Vanuatu, so my coral sample is the coral record that I generated for my PhD is literally from the island that Kennedy swam to after PT 109 sank.
Oh, wow. Yeah.
And you go into these caves and, my grandfather was there. So it was kind of a heavy experience too. You go into these caves and they'll tell you, it's this is where they burned the Japanese out and went in with dogs and down to the last person. And there's museums that are just all of the old, what's left of some of the weapons and stuff. And so, and then Vanuatu, we were in a place called Malakula, which is essentially still very village life. And I mean, in the most, traditional sense is still possible today. And just absolutely if you ever get a chance to go to Vanuatu, the friendliest, most amazing people on earth and the most gorgeous, just mind blowing. So never pass that up. But I went with Fred Taylor, who was kind of my fieldwork mentor, who he had been going to these places and knew some of these chiefs that were allegedly 100 years old. And he's camping out on the beaches in the 1970s and kind of taught me how to do that kind of field work and not burn out, how to do it safely, how to there's inherent risks, especially on the caving side of things. You're going into wild caves where, very few people go to. And then, Vanuatu was uplifted corals. We were coring them. So Malakula has a very well-known uplift rate. So you can find these well-preserved giant coral heads that if you can measure how far above sea level they are, you kind of get a sense for how old they are. And so you're coring these, you're taking canoes with pneumatic gasoline powered drill or seawater gasoline powered coring drills and canoeing to this uplifted coral head and, drilling cores out of it to take back and uranium thorium date and generate climate records from. Vanuatu happens to be an exceptional place for reconstructing El Nino. But that's kind of, And it's funny, you talk to the locals there and they understand climate change. They'll tell you what seasons have changed and things like that. But I mean, I couldn't run out of stories for days. It's hard to even, when you're doing that kind of field work, it just is it's pretty epic. And I feel very
believe you're doing it, right? It's kind of
I feel very privileged to do it. And now I work in Texas caves, like doing some monitoring of drip water isotopes and things like that. And I bring undergrads with me to learn how to do this stuff. And this is a really special protected cave. It contains endangered species, so very few people have access to it. It's a reasonably challenging wild cave. It would not be something that any like random cave loving person would call an easy cave. But I don't tell the undergrads that, because that's another thing about like geosciences is kind of like, I like to avoid kind of like the ego of like, oh yeah, like we're, it's like, I just tell them what they're going to need, like how it's going to go, that we're all a team. Like, here's all of our like kind of safety, like precautions. Here's kind of what we're going to be doing. And they never hear a word about whether it's an easy cave, a difficult cave. Mm-hmm. It's a mile-long cave through a fracture, and there's multiple squeezes that are very, very narrow. And I've never had a single undergrad or grad student like freak out and bail. But I do tell them, like, this is not safety first. This is not a macho environment. No. Like, if you get uncomfortable, I'm always last, like, as we're going through the cave. So it's like, if you get uncomfortable, take a minute, we'll talk through it. If you're still not there, I'll take you back up. So don't ever stress about like, what if I'm down there and I freak out and, they're like, just whatever, we got to do our science. It's like, it's not like that. Like, we're a team. And they get out and eventually it kind of sinks in. They're like, that was pretty like, I was like, yeah, but you did it. And you were amazed. You had fun. They were like, oh yeah, totally. But it's like, I was like, would it have helped you? And it wouldn't have helped me as kind of the person whose project it is to kind of get on an ego trip about like, oh, this cave is scary. It's like, the reality is, as long as like, going in, like how to prepare, how to hydrate, like what our kind of safety protocols are, that you can always like bail at any point. And, it's like, you're there to help me as a part of a team. And it just is. And that kind of is like, we're really glad you didn't tell us. Cause like, you feel like they feel like way more accomplished. And it always is such a rewarding feeling, like to, and it's a self-confidence builder for them, because they may be leading their own fieldwork stuff 10 years down the road. Who knows? Yeah. And that's, I don't know.
That's a great analogy. Oh God.
And, it's just
at the end of the day. It's at the end of the day.
It's kind of, it's just a
metaphor,
pedagogy, philosophy, like, it just is
analogy. Yes.
Yeah. It just is really like, you can do this. Like, if you're stoked on science, like, I don't ever want to, because like with what we face, like, we don't need to be scaring people off. And like, I'm sure, in this podcast, like the leaky pipeline gets discussed, and like, I don't want a leaky pipeline. I want interested, stoked students having a good formative experience doing research, be it in the lab or being it in the field. And, it can be an eye opener for them for how like hard we prepare for the field, and like all that goes into it, and how much of it is safety and how little of it is actually the science part, which is actually quite straightforward. And so that's just one of those favorite parts of the job. So it's just absolutely, so.
Well, believe it or not, we are running out of time.
Oh, I'm sorry.
No, don't ever. No, that's great. This has been awesome.
It's just gone by really fast, which is a good sign. But before you go, we'd like to know if there's anything else you wanted to talk about that we have not covered.
No, man. I really think that kind of given the context of, I tried to did my best to gear my rambling towards kind of what I feel like y'all's kind of mission of communication is. And if I did a bad job, you can tell me, because then I can learn from that. Then I can learn from that for the future. But no,
this work is number one.
Yeah, absolutely. Yeah. So I feel like,
So has, having been at Texas A&M, have you did you already have, or had you had to develop a love for football?
Oh man. Yeah.
No, I mean, football's tough.
This require that before you come to the campus?
Oh no, I'm already host because I got my PhD at that other Texas university.
I was about to say,
no,
regular Texas, and you're at A&M, and that's.
Oh when anybody gives me crap about that, I'm just like, yeah, A&M only hires the best and brightest. They're just like, wait, what?
Oh, that's great. Oh, that's
great. Well, Chris, we'd like to have people be able to reach out to our guests. Is there an email or LinkedIn or something you'd like to share so people can get in touch with you?
There's probably 2 years ago, I would have told you Twitter, but I generally try and keep a low profile in that regard. Like I'm not kind of a look at me type thing, but if they look up my name, my email address is on the Texas A&M website. So if they really have that burning desire, they can get a hold of me. So
perfect.
If they mention that it was through this podcast, I'd be super stoked to answer. So
awesome.
Thank you for joining us.
Absolutely. My pleasure.
Mike, that you were here and that I learned so much more about you.
Yeah. And that's our show. Thank you, Chris, for joining us today. Please be sure to check us out each and every Friday. Don't forget to subscribe, rate, and review. See you, everybody.
Bye.